Hello everyone, welcome to my channel CAPSA. Today's topic is the second part of pharmacodynamics, that is dose response curve. Or today we will understand what do you understand by DR curves, okay, that can be graded or quantal. We will understand step by step. So what is graded or quantitative or quantal dose response curve? Actually, it is achieved by plotting dose or log dose on the x-axis and by plotting response of drugs or agonists on the y-axis. Okay, and to reveal the information about affinity, potency, efficacy of agonist, we will need this kind of curve. Okay, so we will see how the dose response curve acts. We are taking another color. This is x-axis and this is y-axis. We will write log dose in the x-axis and we will write the percentage of response on the y-axis, or we can write like magnitude of response. Okay, now we will see a graph. If we apply a drug, then we can see a curve like this. Okay, now this point is when 50% of drug or agonist bind the receptor, we will get this kind of graph, and this point is known as ED50 or EC50. ED50 means median effective dose or median effective concentration. Okay, now this point is known as intrinsic activity, which used to denote the efficacy of a drug. Clear? Now, what do you understand by graded and quantal dose response? Graded dose means when you are increasing the amount of dose, you will get the increasing effect or response. In quantal dose, when you are increasing the dose or amount of dose, you can get decreasing effect, or you can get increasing effect or response, or it can be present, absent, or it can present. Means response can present or response can absent. Okay. Now, what do you understand by ED50? I have told that ED50 means the median effective dose. Okay, it means the dose of a medication that produces a specific effect in 50% of the population that has been administered that dose, or we can say like dose in mg per kg, which produces a desired response in 50% of test population. So we can write like dose which will be represented in mg per kg, which produces a desired response in 50% of test population. It means you are taking 100% or 100 amount of people. Okay, among these, if 50% of people get the desired response in that amount of dose, that is denoting as ED50. Okay, now what is LD50? Okay, LD50 means median lethal dose. Okay, or we can say that the dose of a medication or medicines that produces a toxic effect or killing effect in 50% of the population that has been administered that kind of dose. Or you can say like dose in mg per kg, which would be expected to kill 1/2 of the or 50% of the test population belongs to the same species or strain, and it is used to indicate or calculate the mortality rate of population. So we can write like dose in mg per kg which would be expected to kill 1/2 of the test population known as LD50 or lethal dose. Okay. Now, if we put these two values in a ratio, we will get therapeutic index. So, LD50 therapeutic index or therapeutic index is the ratio of LD50 and ED50. Okay. Now, always keep in mind, to be a safe drug or to consider a drug which is safe, you need to get the value LD50 value more than ED50 value. Okay. So this is considered as a safest drug. Okay. So if the value of therapeutic index is more, then it considered as the safer drug. Clear? Because now why we need this value? Because after comparison between ED50 value and LD50 value, then we can evaluate how much the drug is safe for our population. Okay. So we need the therapeutic index value to be calculated. Now, when a drug binds to a receptor, a chemical force attracts them to each other and they forms a chemical bond between them. Means the drug with the drug and the receptor. Okay. This kind of bonds are, it can be ionic bond, it can be covalent bond, or it can be van der Waals bond. And it is considered that covalent bond is the strongest bond in the drug receptor complex formation, which can be irreversible. So drug receptor complex formation is always irreversible in nature. Clear to you? Now we will see a mathematical formula which represents the drug receptor interaction mechanism. Okay. So this is the drug, this is the receptor. After binding, they forms DR complex and get the therapeutic response. This value is known as K1, this is K2, this is K3. Okay. Here D equal to drug, R equal to receptor, DR is the complex or drug receptor complex. K1 This constant is association constant. K2 is known as dissociation constant. Okay. And K3 is used to calculate the intrinsic activity. Many mathematical problems ask from this kind of equation. Okay, so you need to remember all the things of this equation. Now we will see a graph which represents the therapeutic index in form of therapeutic window or a range. Okay, we will draw another graph. This is x-axis, this is y-axis. Here we will write time, here the drug concentration. Okay, we will get this kind of curve. Okay, this is the area. This curve is known as AUC curve, also known as area under curve. This area is known as area under curve. Okay, and this concentration is known as MEC or minimum effective concentration, and this concentration is known as MTC or minimum toxic concentration. Okay, and the space between these two is known as therapeutic window or range. If this therapeutic window is more or larger, then it is considered as that the drug is safest drug. Okay. Now, how will you get this therapeutic window? When you increase the dose, first you get the effective concentration. Then, after increasing continuously, you will get the toxic concentration, and this is that is represent the therapeutic window or therapeutic range. Okay. Now, you have learned previously about the agonist, antagonist, all these things. Now we have learned about DR curves. So we will see how these agonist, antagonist, partial agonist, how they act through the DR curve. Why we need this DR curve. Okay. So we will draw a DR curve. We know that to draw DR curve, we need to write log dose. Always remember, in the AUC curve, in the x-axis, you will write time, but y-axis concentration. But in DR curve or dose response curve, you will write in the x-axis, that is log dose. In the y-axis, you will write the response. Okay, now you will get a curve like this. This curve represents inverse agonist because the opposite effect of agonist. That's why this is negative curve. Okay, that is the antagonistic curve. This curve represents the partial agonist. Because antagonist does not produce any effect, so you are seeing like a straight line, and partial agonist produces a less response than the agonist or full agonist. That's why you are getting this kind of curve. So this is full agonist. Okay, and this line represents the constitutive activity. Clear to you? So this is the end of my second lecture. In the third lecture, we will see what are the factors modifying dose response relationship. What are the type of receptors in details. Okay. Thank you for your attention.